Okay, today we are going to start an introduction to circles. For this first part, you might want to grab a piece of paper and just jot down some key terms. This is not on the note sheet that you're going to complete. Okay, so these are just side terms. So a circle is a set of all points in a plane that are equidistant from a given point called the center of the circle. A circle with center P is called circle P. Okay, so take a minute, maybe push pause, jot that down. If you want to see a visual, P. Okay, circle P. The next term, a segment whose endpoints are the center in any point on the circle is a radius. So take that same picture. So, for example, this would be a radius. It's a segment whose endpoints are the center. So this is our one endpoint, and any point on the circle. So that, okay, so that's a radius. A chord is a segment whose endpoints are on the circle. So if you take a look at this, picture, this is a chord. I could draw in one here. This is a chord. Okay, its endpoints are on the circle. Okay, diameter, which I'm sure you're familiar with that term, is a chord that contains the center of the circle. So notice its endpoints are still the sides of the circle. It just goes through the center as well. So we can draw lots of different types of chords. That's another chord. Okay, that could be a chord. Okay, so take a minute if you need to jot these down. Push pause if you need to get these key terms down. Okay, two more terms here. A secant is a line that intersects the circle in 2 points. So the key difference here between this and a chord, sorry, I wasn't writing, is this is a line. So a secant, as you can see in this picture, comes through as a line and it cuts and hits the circle at 2 points. A tangent, okay, a tangent is also a line in the plane of a circle that intersects the circle in exactly 1 point. So as you can see in this picture, it's just coming through and hitting it once. It doesn't actually go inside or into the circle. Okay, that point where it hits, this point right here, is just a point of tangency. Okay, once again, take a second if you need to jot those down. Push pause. Now, just so you're cool, follow through with these terms. It says, tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent. You don't need to write these down, just follow through with me so you can see examples of these. So if we look, AC, I'm off alignment, is just a radius. Endpoint is the center and the edge of the circle. Okay, B, AB would be the diameter, and since it's a diameter, it's also a chord. Its endpoints are on the edges of the circle. Okay, now look at this, ray, DE. So if we go ray, DE. Okay, now technically, it would be a tangent, and it should be a line. I'm going to go with that might be a typo. Okay, and then line AE, it's coming through hitting twice, so that is a secant. Okay? All right, next slide. This picks up with the note sheet from my website. So we already wrote down the definition of a tangent. It's a line in the plane of the circle that intersects the circle in exactly 1 point. If you want to write it twice, by all means you can, but you don't need to. Okay, so on the note sheet then, under theorems, there are 3 key theorems. If a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So just so you're clear, maybe a little visual jotted in the margin. Okay, if I draw in a tangent, let's pretend that's a tangent. Okay, and then I draw in a radius, that point is going to be perpendicular. Okay, a tangent line is perpendicular to the radius. Okay, the second one, if a line is perpendicular to the radius, then it must be the tangent. So that's just the reverse statement. And then the third one, once again, if at any point I go too fast, just push pause. If 2 segments from the same exterior point are tangent to the circle, then they are congruent. related to this. So under the verifying tangency section, there are these two figures for you. Fill in, okay, if this is 11, and this whole hypotenuse here, well, segment, we don't know that's hypotenuse yet, is 61, and this is 60. If we want to verify that this is indeed a tangent, we need to see if this is a right angle. We're not sure yet. So we can verify this by doing Pythagorean theorem. If it works, it's tangent. If Pythagorean theorem doesn't work, it's not tangent. So 11 squared plus 60 squared, we want to know, does that equal 61 squared? Punch it in your calculator real quick. You should see that yes, indeed it does, so it is tangent. Okay, on your second circle, I want you to take these values, 3, 7, this whole segment here is 8. I want you to take a second and see if Pythagorean theorem works. So push pause and try that. We want to know, does 3 squared plus 7 squared equals 8 squared? And it should not, so no, it is not tangent. Okay? Go to the bottom 3 tangent examples. So let's fill in these values. R, 16. Now R represents radius. So R is just representing this piece and that piece. And then 8. 8 is just this outside piece. We want to solve for R. So if indeed this is tangent, so I'm telling you this is tangent, I want to solve for R. Well, if you think about it, this is a right triangle, so we can use Pythagorean theorem. So R squared plus 16 squared should equal this whole side. Well, this whole side is really R plus 8, not R times 8. Add the segment length, so it would equal R plus 8 squared. So go through. You need to FOIL this. Do not tell me it is R squared plus 64. You need to write it out twice and FOIL. So you should have R squared plus 16R plus 64. Now let's solve for R. Well, we have an R squared on each side, so they should cancel out. Okay? Then we have 16 squared is 256. And that equals 16R plus 64. If you keep going and solve, you get R to be 12. Okay? This second one, this is R and R. This outside piece is 6 and this is 12. I want you to take a second, push pause, set this up and solve for R, please. Just like number 1. Did you get 9? If so, good. If not, go back and check your work. All right, example 3. If I tell you this is 50 plus x, and this is 2x minus 15. They're two tangents. They're coming from the same exterior point. Just set them equal. So please copy this down with me. Subtract x, add 15, and x is simply 65. Okay? All right. Flip to the back. We're going to start chords. So we already wrote down the definition of chords, so if you want to rewrite it, you can. If not, I don't care. There are 4 arc and chord relationships. So the first one here, and don't worry about the numbering here, okay? They're just 1, 2, 3, 4. Chords of a circle are congruent if they intersect congruent arcs. Okay, so we'll do examples with all of these. So we have 2 chords. They're congruent. These guys are congruent if these arcs are congruent. Like I said, we'll do examples. Okay, the second one. 2 arcs. Oh, that's 2 arcs. 2 arcs of a circle are congruent if their chords are congruent. So that's just the reverse of number 1. Number 3. The perpendicular bisector of a chord of a circle contains the center of the circle and bisects the arcs of the chords. That's a lot. So let's draw a picture here. So this is for 3. I have a chord. The perpendicular bisector of the chord. So if I draw in a piece like this, pretend that's perpendicular, long as it is perpendicular and bisects the chord, then it must contain the center of the circle. So that means it's part of a radius or diameter. And it bisects the arcs. So these arcs would then be cut in half. We'll do examples, don't worry. And the fourth one, two chords are congruent if they're the same distance from the center. So visual here. This is my center. And let's say to this chord is 3. And then to this chord is 3. Then that means these chords must be the same length. And like I said, we'll do examples. If at any point I go too fast, just push pause. We're almost done. The chord examples go actually really quickly. If I tell you this arc is 108 degrees and this arc is 108 degrees and this is 7 and this is x, then x must just be 7. Arcs are congruent, chords are congruent. Now this one, let's go the other way. If this is 9 and this is 9, and this is 83 degrees and this is x, if the chords are congruent, then the arcs must be congruent. So this must be 83 degrees. Okay, so they're examples of the first two theorems, forwards and backwards. Now, in this picture, okay, we have a center point. This is a center point, and this is a chord, and it's perpendicular. So if it's coming from the center and it's perpendicular, that must mean these are bisected. So if this is 6 and this is x, well then x must be 6. Okay, this is coming down to the fourth theorem. Example 4 is talking about the fourth theorem. So this is a center point, and these guys are perpendicular to two chords. If I tell you this is 4 units from the center and this is 4 units from the center, then I tell you this is 8 and this is x. Rocket science here, I know. Then x must be 8. So if they're the same distance from the center, they must be congruent. Last example, and then we are done. We have a center point coming in perpendicularly to a chord. Okay? If I tell you this whole piece is 18, and these are x and y, can you find x and y? You got it. They're both 9. They're bisected. Okay? We will recap all of this and start to do some practice tomorrow in class. Make sure you have down good notes for all of this, though. Okay? Have a good night, and I will see you tomorrow.